Welcome Algebra 1 students to Lesson 36. And the name of our lesson today is Distributive Property of Rational Expressions that contain positive exponents, minus signs, and negative exponents. And that is a mouthful. So let me break it down. We learned how to distribute a while back, right? We learned that A times B plus C is the same as AB plus AC. Basically saying that we created a rainbow, we multiplied A times B and we multiplied A times C. And we kept the operation in the middle in the event that we could add them when we were done, right? Okay, that's distribution. Then we started doing distribution on fractions. So 1/3 times 1 or 2, let's say 2/4 plus 3/5. We were able to say, okay, 1 times 2, that's going to be 2, and 3 times 4 is 12, plus 1 times 3 is 3, and 3 times 5 is 15. And then we were able to find a common denominator and add those two fractions together. We're going to do that again, but this time we're going to use fractions with variables that have exponents. Okay? Same thing, just getting a little bit more complicated. This is where the repetition of algebra starts to kick in. You understand the pattern. You understand that you're going to do the distribution. You just have a little bit more complicated number this time. So you're honing your skill. You're refining it at this point. You're not learning a new concept at all. You know how to do this. Now you just have to know how to do this with exponents. That's all we're doing. So let's jump right in. And we're going to use the distributive property on 36.1. And here is our problem. We're going to use the distributive property to expand x squared over y squared times x squared over, that's an x, over y minus 3y cubed over m, and that's the total expression. So here's how we're going to do this. We're going to again write the entire, Roscoe, hush, I don't know what he's barking at. We're going to write the entire first fraction here. We're going to make a longer line, and we're going to write x squared over y squared because that's our original fraction. Now we're going to bring down the first fraction, and we're just going to write it next to it, x squared over y. Bring down our operation, make another little line, write the fraction that we're distributing again, and then we're going to bring this fraction down right next to it. And then what's underneath it? Okay, so this is our distribution. This is our A, this is our B. This is our A, this is our C. So it is the format of AB minus AC, just like we did before, where we had A times, well, this would be B minus C, right? That equals AB minus AC. It's the same thing. Here's the A, here's the C, just like that. Now we do what's called the squish. The squish is merely adding like terms, but my son really likes the word squish apparently, so he prefers that term. So it is essentially what we're doing. We're squishing everything that's alike together. So let's do that. x2 and x2, they're the same variable, so we can add the exponents and get x4. We have a y2 and a y to the 1, so we add the exponents and get a y to the 3. Bring down our operation. All right, we have an x2, 3, y3. No like terms there, so we just write them out, but we write them in the right order. We always want our coefficient, or our whole number, that is, our constant, to be the first number, all right, the first digit. And we're just going to write x2, y3. It just looks neater that way. And now we have m and y2. And I'm just going to do it in alphabetical order, m, y2. Just because I can, no special reason. So that's our distribution. That's all we have to do. You just apply a, or the first fraction, to b, which is the first fraction inside the parenthesis. Bring down the operation, and then apply a to c, which is the second fraction in, and then you end up with two fractions here. All right? All right, and you can see how that distribution works. It's just what's across the top stays across the top. What's across the bottom stays across the bottom. The two do not mix, right? Not yet. We'll work that out later. So we have this, but we just learned about canceling, right? We canceled in this last one. Do we see anything where we can cancel? Well, in the first fraction, we have x to the 4, y to the 3. Those are completely different. We can't cancel anything out there. But in the second term, we have y on top and y on the bottom. So we can cancel there. We could actually subtract this y squared, or we could factor out the y squared, not subtract it. We're canceling it, which is kind of subtraction, but not really. So here's how we're going to do that. We're just going to rewrite this one just like it is. We can't do anything to it. But I'm going to take this one, I'm going to write it over here. 3x squared, and then I have 3 y's. Y, y, y. And then I have m, y, y. I could take this one and I could take this one. So that leaves me with 3x squared y over m. This is the final simplified version of all of this. If you stop right here when you give me your answer on Jupiter Ed, I might give you 0.7 or 0.5, but don't be lazy. Go after the whole point. Get the whole thing correct. If you just take 0.5s and 0.7s and you don't finish out the problem by canceling, guess what? The best you're going to do is a 50 or a 70. So go ahead and solve, do the cancellation, apply what you've learned. That's the whole point, is to learn it and use it, not just learn it for the sake of knowing it. So let's do 36.2. If you will write it down as I am writing it down, as we have discussed before, then it saves time in the long run. It's supposed to be a K. This pen skips every now and then. All right, so here's our problem. Okay, Miss Tracy, we can't distribute because I have one fraction and one whole number. We can turn a whole number into a fraction. Don't forget. Remember, you just put it over 1. Now it's a fraction. Now you can distribute to both of these. Easy peasy. It's not hard. You just have to remember. So we write the first one, m AXP, Z on the bottom, MK, right? Minus, that's our operation. We put another line in here. M and Z is our first one. 2M, 4, P, 4. And we don't have to write the 1 because we know it's there, right? Anything times 1 is 1. Or anything times itself. Anything times 1 is itself. That's what I meant to say. All right, so now we can do the squish, but we can also do some cancellation. In this squish, we can see that we have an m on the top and an m on the bottom, and they will cancel. We'll factor those bad boys out. They are gone. So now we have AXP on top and ZK on the bottom. And we bring down our operation. We draw another line. We bring our constant, which is our coefficient whole number, to the front. And we have m to the 1, m to the 4. That's going to be m to the 5. P to the 4. And then z by itself. And that is our final answer. We can't get rid of anything else. That's all we can do. All right, so let's look at 36.3. I think I can fit it right here. Copy as I write so you can save some time. All right, and here we are. This is an x. This is our expression. We're going to distribute. So this time we have 3 terms. That doesn't change anything. First fraction, we write that down. Bring down our operation. Second fraction, we write this down. Remember, this is over 1. That's how we turn a whole number into a fraction. So 2bx. And we don't have to put the 1. Minus. All right, now we squish. We have 2 a's. We have 2 b's. 1x. We have C2, C1. Bring the constant to the front. We have an A. We have 2 b's. An x. C squared stays. Then we have a 4 AB. We have 2 c squares, so that becomes c to the 4. All right. Very good. Let's see, is there anything we can cancel? We don't have any c's up top. So I believe that is it. I'm looking at my answer in the book. And that is correct. That's as far as we can go with this. All right. Now that is all I have for distributive property of rational expressions with positive exponents. Let's look at some minus signs and negative exponents now. So we know that if we have this, it's this, right? And we know that if we have this, it's this, right? The negative makes it flip. And we know that if we have this, then we have this. We also know that if we have, then we have this. Because the negative has to be enclosed in parentheses in order to be included in the square. If it's not enclosed in parentheses, then the negative sign is not included in the square. So that would make your result negative. All right, knowing all of this and knowing how a negative exponent causes whatever this is to flip from the top to the bottom or from the bottom to the top, let's put that into play with some expressions here. And they did not give us any example problems for this. Not any at all. Well, that's just not good. So let me find us some example problems with this. Let's see. All right, so we have let me look over here and see what I have. Surely we have some example problem that, here we go, here's one. All right, so we have x to the negative 1 over y times y over x. And then we have minus, and then we have another expression here that is 3xy to the negative 5. That's a y right there. And then that's over p to the 6. And that is the expression right here. So now we're going to multiply. We're going to say x to the negative 1 over y. And then we have y, and then we have x, right? Minus, and then we're going to put our x to the negative 1, y, and then our second fraction. And then p to the 6. There we go. So how do we evaluate this? What do? Well, first of all, let's make all the exponents positive. So let's take this off the top and put it on the bottom. Now it's just x to the 1, right? Let's do the same thing over here. Let's take this and put it down here on the bottom. And let's take this and put it in the bottom. And that becomes y to the positive 5. So now we can do some cancellation and see what we have. In the first fraction, we have a y on the top and a y on the bottom. And we know we have the invisible 1 here. So when we cancel those out, we have 1 over x squared minus, and we have the line here. We have 3x on top. Actually, technically, we can go ahead and cancel this x with this x, right? So we only have 3 on the top. And on the bottom, we have y1 and y5, which gives us y6 and p6. And that would be all we have for this problem. That's it, simplified. Because we were able to flip and cancel, flip and combine. So here we flipped and combined, and then we canceled, and we flipped and combined and canceled. All right, so that is a really good example of how to do distribution with the negative exponents. Go ahead and distribute. Keep the exponent negative. Just write it all together and then evaluate what you are given. All right, that's all I have for lesson 36. Is that what lesson we're on? I think it is. Yes, that's lesson 36. So I will see you guys in lesson 37. If this is confusing, take it one part at a time. Don't rush it. Just look at each individual part and compare. Write it big if you need to. Get you a little dry erase board and practice. Write it out on that and see what you can do. All right, I'll see you guys in lesson 37.